Hi everyone, it's Alyssa and welcome to Tricky Math Tuesdays. Today's tricky math problem is one somebody sent to me. Oh, that's not great. It has to do with a triangle. There we go. Okay, so I'm given that I have this right triangle, given that this side is 9, this side is 12, and that we have this is called an altitude, is what comes straight down and makes a right angle. All right. It makes a right angle. Okay. And I'm also told that I'm calling this little portion X, this Y, and this Z. And they want to know what X, Y, and Z are. Okay, there's going to be a lot going on in this one. It just is. So I will do my best to just really break it down. But yeah, this one's going to be interesting. And it doesn't have a nice, neat, pretty answer at the end. I'm a fan of nice, neat, pretty answers, but this is not one of them. Okay, so first things first, what do I know? Well, I know this is a right triangle. This whole big thing is a right triangle. So what's going to come up again and again and again is the old standby, the Pythagorean Theorem, a squared. I am going to need to turn off this ink to shape feature because it's going to make all my C's into circles. A squared plus B squared equals C squared. So if this is my A and that's my B, I can find out what my C is. So 9 squared plus 12 squared equals C squared. 9 squared is 81, 12 squared is 144, and that adds up to 225. So 225 is C squared. So I take the square root of both sides, and C is 15. Something you might have noticed, this is a variation on the very common 3, 4, 5 right triangle. So it's 3, 4, 5. So here you see 3 times 3, 4 times 3. Other side's going to be 5 times 3. If you haven't seen a 3, 4, 5 right triangle before, if you're in geometry, you will. Okay, so I figured out that this other side, come on eraser, there we go, that this other side is 15. This whole thing is 15. So that's my first little thing I know now. I know that X plus Y equals 15. What else do I know? Well, I can look at these. I looked at the big triangle. Now I'm going to look at these little smaller right triangles. So here, this yellow one, I know that it is a right triangle, so it's going to follow Pythagorean Theorem too. So X squared plus Z squared is going to equal 9 squared, or 81. So I'm just doing A squared plus B squared equals C squared. Now I'm going to look over at, I do here in green, this triangle. And that triangle, I know that Y squared plus Z squared equals 12 squared, or 144. Okay, so this is my starting point. These are 3 things I know because of what they've given me. There's too many variables going on. I need to eliminate some variables. Well, first off, my eye is drawn to these 2 because I have Z squared in both of them. Well, if I multiply one of these all the way through by -1 and then add them together, the Z will be eliminated. This is a solving system of equations by elimination. Because there's so much going on in this problem, I'm not going to go into a lot of detail on that. If you'd like more detail, please go to the video in the link below. I walk through all the steps on this and why it works. So I'm going to multiply this whole equation here by -1. I'm going to write it down here. So that gives me -x squared minus z squared equals -81. And I'm going to bring the other one down. Y squared plus z squared equals 144. So I can add those together, and I get y squared minus x squared, and the z squareds cancel out. And then 144 plus negative 81 is 63. Right, so now y squared minus x squared equals 63. This may look familiar as being a difference of squares. If that doesn't mean anything to you or doesn't ring any bells, link below. It's a thing having to do with factoring. So, yeah, I thought you're in geometry. We wouldn't have to do factoring or algebra. It always comes back to bite you again. So y squared minus x squared equals 63. It's a difference of squares. So it's the same as y minus x times y plus x. You go, okay, well, how does that help me? This is why it helps you. Is up here. X plus y equals 15. Oh, x plus y and y plus x, that's the same thing, isn't it? Yes, it is. So, and it's not letting me zoom out. There it goes. Okay. Why is this thing being so persnickety? All right, so y plus x is 15. So I am going to, first I'm going to change my color because I want it to be, let's make it green. All right, so that's going to be 15. And y minus x just stays there and equals 63. Okay, so I'm going to divide both sides by 15. And I get y minus x equals 63/15. And I can simplify that because 3 goes into both of them, into 21/5. Okay, so now I have two equations. I have this equation and I have this equation where all I have are x's and y's, and one already has a negative x in it. So this is another substitute, oh, excuse me, not substitution. This is another system of equations that we're going to solve by elimination because it's already set up that way. So I'm going to reorder the x plus y to be y plus x equals 15, just because I can. Then I'm going to take this down here and I'm going to rewrite it. So it's y minus x equals 21/5. Don't you love fractions? Add those together and I get 2y equals 21/5 is the same as 4 1/5. So I get 19 1/5. 2 times y equals 19 1/5. Like, okay, so now I need to divide both sides by y. And I get that y equals 9 3/5. Okay, well now I can solve for x because I know y plus x equals 15. I'm actually going to mark that since we have that as a solid one. So y plus x equals 15. And I know now that y is 9 3/5 plus x equals 15. Subtract 9 3/5 from both sides. And x is equal to 5 2/5. And we'll do them different colors. Why not? And there's my x. So now to solve for z, our last one here, we can go up to either of these and solve for it. Doesn't matter which one. I used the y squared plus z squared myself when I did this, but it doesn't matter. Both of them will work. So if I said y squared plus z squared equals 144, and just to make this a little easier on myself, I'm going to convert this fraction, 9 3/5, into an improper fraction, which in some teachers may want you to write it that way anyway. Like this x, 5 2/5 is the same as 27/5. And this 9 3/5 is the same as 48/5. That may be how your teacher wants you to write it. You know, for this kind of thing, defer to what they're telling you. So I'm going to put this up here, 48/5 squared plus z squared equals 144. Okay, 48/5 squared is, 48 times 48 on top, 5 times 5 on the bottom. 48 times 48 is 2,304. 5 times 5 is 25 plus z squared. And I'm going to convert this 144 into 25ths just to make it a little easier here. And that is 3,600 25ths. Then we subtract 2,304 25ths from both sides. I told you it wasn't pretty. And I get z squared equals 1,296 25ths. Okay, so now we're in the home stretch. We take the square root of both sides. So what that means is z is equal to, when you say square root of 1296 over 25, that's the same as the square root of 1296 over the square root of 25. And if you pop that in your calculator, the square root of 1,296 is 36, and the square root of 25 is, of course, 5. So there's our other one. So we have our final answer. So I'm going to write them over here on the left. I'm going to make it very bold here. Okay, so our x is equal to 27 fifths. Our y is equal to 48 fifths. And last, but certainly not least, our z is equal to 36 fifths. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.